Welcome to our 8th video in which we look at a graph and we determine the parameters which make that graph. Well done for listening to the previous two videos. There's a lot of theory there. In this video we apply the theory to some questions. Little bit of a recap from what we did before. I should have said all these equations we saw in the last video refer to both of these graphs, the sine graph and the cosine graph. And also in the previous video I made a little bit of a mistake for the range. This is the correct version. And remember, the period, some people like to write relationships like that in a triangle, where we have period is 2 pi over b, and that tells us b is 2 pi over the period. And if you really want, it also tells you 2 pi is period times b. Okay, let's see a question. I made this one up, and I should tell you at the beginning c is 0, but the task is, from this orange graph, how can we determine the values of a, b and d? Well, let's focus on these for a moment. We can see the maximum value of the function is 6, and we can see the minimum value of the function is 2. So replacing that in this equation, we've got 6 minus 2 over 2, which is 2 for the value of a, and here we've got 6 plus 2 over 2, which is 4 for the value of d. So that's a good start. Let's look at the value of b. b is related to the period. Now, you can look for the period as the length of the part that repeats, the shortest length of a repeating part of the graph. Now, if you look closely at that part of the graph, that's one cycle. And here is another cycle. And here is another cycle. And they all fit in to one cycle, of the sine graph, which is 2 pi. So 3 cycles fit in to 2 pi. Well, that means the period is 2 pi over 3. And that will tell you that the value of b is 3. Okay, so let's test these values. So we figured out that a was 2, that affects the amplitude. We figured out that d is 4, that affects the principal axis. It's a vertical translation. And we figured out that b was 3. That's a horizontal stretch of factor 1/3. And here's our graph. Not sure you can see that. That's the graph we're aiming for, and this is what we've calculated. So we got it right. Very good. And we can actually put this graph back in its place. Like that. Okay. Let's do another example. Now this one I've adapted from an exam question, and this is the form we're given. Y equals P cosine QX. So as I said, it's a little bit, takes a little bit of thinking that all these formulas here are in terms of A, B, C, D, but sometimes you may need to operate with other letters. So let's think about, what does P tell us? Well, P is outside the bracket, it's vertical, it corresponds to the amplitude. Okay, and in this graph, we can see the maximum value is 30, and we can see the minimum value is minus 30. Okay, so if we do maximum minus minimum over 2, we will get 60 over 2, which is 30. Now that gives us the value of the amplitude, and actually you can see it from the graph. If you look at that distance, it's obviously 30. Okay, and what does Q tell us? Well, that's inside the bracket, so it's horizontal, and it affects the horizontal stretch and the period. So let's look at the period of this graph. Well, here, this is a repeating cycle right there, because then it repeats. Let's look at the length of that repeating cycle. This length is pi over 2. So the period is pi over 2. And from our little triangle, B is 2 pi divided by the period, which is 2 pi over 2, and that is 4. So there we've worked it out. P is 30 and B is 4. Let's look at another example. Well, see here, it's another case where the P and the Q are put in any place. It's important to interpret them correctly. So here we can see both P and Q are outside the brackets, so they're vertical, and with a bit of studying you will see that Q is the amplitude and P is the value that gives us the principal axis. Okay, in this question we're given that the maximum is 3 and the minimum is minus 1. Okay, so we can determine Q as maximum minus minimum divided by 2. Okay, that gives us a value of 2. And P, which is the vertical shift, in other words the principal axis, is maximum plus minimum divided by 2, which is 1. If you look at the sketch, you can see the principal axis there in the middle is 1. And that's it. Okay, now in class you'll practice some examples like that. Thanks for watching, and here is a scene of a Highland cow from my own beautiful country.